Our previous topic is about arithmetic sequence. And as you could recall, the formula for arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. And you know that when we talk about arithmetic sequence, the d means difference. And what does that mean? You have to think about a number that you added or subtracted to the first term to get to the second term. So let's have an example. Okay, example. Just for you to recall, let's say we have 4, 7, 10, and then so on and so forth. Now look, how do you think 4 turns to 7? The next term is 7. So we added 3, right? How about 7? Becomes 10. So we added 3. Therefore, the D here is 3. With arithmetic sequence, the important thing there is what number you added or you subtracted to get to the next term. Now our topic is about geometric sequence. Now with geometric sequence, the formula there is a sub n is equal to a sub 1 times r raised to the power of n minus 1. So what does that mean? It means the r here is ratio. So what does we mean when we say ratio? So it means from the first term to the second term, you got to think of a number you multiplied to the first to go to the second term. It's either you multiply or you divide. But for our example this time, let's go first for the number you multiplied. So let's say we have 4, 12, and then 36, and then so on and so forth. So now look for 4. What's the difference between 4 and 12? 8, right? Could the difference between 36 and 12 be 8? No. So therefore, this is not an arithmetic sequence. Let's check for the multiplication. What number you multiply to 4 that could become 12 for the next term? Yes, 3. Now, try to think again. Multiply 3 also to 12. If you multiply 3 to 12, will it be 36? Yes. So therefore, this pattern shows geometric sequence because what we have here is the ratio or the number you multiply to the previous number to proceed to the succeeding number. And the number we multiplied to is 3. So again, for geometric sequence, you think about a number that you multiplied to proceed to the next number. So let's have another example. What if we have negative 13, negative 26, negative 52? What do you think happened? The 13 becomes double, right? Because when you multiply 2 to 13, it becomes 26. How about 26? Will it, when you doubled it or multiplied 2, will it be 52? Yes. But with this example, yeah, we did the 2. We multiplied the 2 or the ratio is 2. But let's check the sign. Negative times positive is negative. Very good. And then negative 26 times positive 2 is negative 52. So still, the ratio is 2. And then, let's say you are looking for the 9th term. So what is 9th? That is your n. Our n is 9. What's the formula again? For solving or finding the n term using geometric sequence. So that is a sub n is equal to a sub 1 times r raised to the n minus 1 power. Now, look here. A sub n will be a sub 9. A sub 1 again is always the first term. So that is negative 13 for this example. You put it in inside a parenthesis because it's negative, just to be sure you will not make a mistake with the sign. What is our r? R is 2. What is our n? N is 9, so that is 9 minus 1. So let's rewrite. So bring down negative 13 and then times 2. 2 is raised to the 8th power. So with this one, as what we're going to do, we will be using a calculator because this part, 2 to the 8th power, means you will be multiplying 2 to itself how many times? 8 times. So 1, 2, 3, 4, 5, 6, 7, 8.